Okay, so excuse me. We're in section 9.5 where we are going to be able to graph and write equations of hyperbolas. This is the last of the four conic sections that we are going to be working with, and it has some similarities to our equations for ellipses, but the one big difference is that instead of adding the equations together, we're going to do subtraction. Um, Similar to the ellipse, we still have two foci. We have vertices, but what changes is we have what is called a transverse axis. The transverse axis is a line that passes through the center and tells us the distance of our two vertices that are together in our excuse me, in our hyperbola. One thing to note, which is right here, is that A always comes first in when we're dealing with hyperbolas. The things that changes now is either the x squared is in front or the y squared is in front. So let's take a look at this first. Let's go down here, and this is x squared over a squared minus y squared over b squared equals 1 is considered a horizontal hyperbola, and it looks kind of like this. Okay, and first off, this when it talks about the transverse axis, so the transverse axis is the distance between here and here, and that's denoted by 2 times a. So the transverse axis here is horizontal. Okay. Second thing we have is what is called asymptotes. Asymptotes, again, it's made up of two lines, and both of the lines cross at the origin 0, 0. So it looks something kind of like this. They're usually represented as dotted lines in our graph, and these ones are denoted as y equals plus or minus whatever b is over a times x. So that's how we get those lines. If we're dealing with the vertices, it's a coordinate, and they're located here and here. This one is denoted at coordinate a comma 0, and this one's at negative a comma 0. So when I go up to here, it's plus or minus a comma 0, and the foci is again denoted by c, and this one is on the outside of our hyperbola, which could be located here and here, and the coordinates are c comma 0 and negative c comma 0. So if I were to write this here in our equation, it's going to be plus or minus c comma 0. The last thing would be our covertice, which would be our b, and that would be, say, located here and here, and this would be located at 0 comma b, and here would be at 0 comma negative b. So when I fill the chart in here, it would be 0 comma plus or minus b. So just like we had with our ellipse, we have our vertical hyperbola, which would look something like this. Okay, so we have our transverse axis, which would be located here, which is denoted by 2 times a, that's the distance, and this would be a vertical line. Our asymptote is just the opposite of what we had here. So if it was in the horizontal hyperbola, it's y equals plus or minus b over a. This one's going to be y equals plus or minus a over bx. And then, again, the same thing. It crosses at the origin 0, 0, and that's how we get that. Next thing we have is our vertices. Again, here they were at plus or minus a comma 0, so it's just the opposite. It's going to be 0 comma plus or minus a. And then when we draw them on here, it's going to be 0 comma a, and this one's going to be 0 comma negative a. Our foci will be located here and here. Again, it's going to be 0 comma c, and this one's going to be 0 comma negative c. So I'll just write that in, 0 comma plus or minus c. And then the last thing is going to be our co-vertices, and this is going to be plus or minus b comma 0. So it's going to be on the x-axis. So it's going to be somewhere around here and here. This is where our negative b comma 0, and this is where our positive b comma 0. And those are all the things that we will have to look for when we are dealing with finding the equation for hyperbolas. And these things here will also help us out when we solve them throughout the particular problem. If we are given just the foci and maybe one of our a or b coordinates, we can solve it by using c squared equals a squared plus b squared. You remember before that when it was an ellipse, it was c squared equals a squared minus b squared. This makes sense now because my c is actually larger than my a in this case. Before in the ellipse, it was not. So keep that in mind. So for this example, they want us to graph the equation of the hyperbola, and then they want us to label the foci and the asymptotes. So let's, first thing out, we have to get this value here as 1. So I'm going to go x squared minus 4y squared equals 8. I'm going to divide all that by 8. So this becomes x squared over 8 minus y squared over 2 equals 1. So since a is always in front, this is denoted as a squared, and this is going to be denoted as b squared. So a is going to equal square root of 8, and b is going to equal the square root of 2. C in this case, all we have to do is remember the whole c squared equals a squared plus b squared. So a squared is 8 plus b squared, which is 2. That gives me 10. So taking the square root of that, c is going to be the square root of 10. So if I want to plot these points, my vertices are going to be plus or minus the square root of 8, comma 0. And my foci is going to be plus or minus the square root of 10, comma 0. So the square root of 8 is roughly 2.8, so it's almost like 3. So here and here are going to be the points for my hyperbola. Okay. Next, they want us to do the asymptotes. So the asymptotes for this case, because I know it's a horizontal ellipse, it's going to be y equals, and it's plus or minus b over a. So it's going to be the square root of 2 divided by the square root of 8. Now, usually you don't keep the square roots in the denominator, so I'm going to multiply both sides by the square root of 8. So this becomes y equals plus or minus the square root of 16 over 8. Square root of 16 is 4. 4 divided by 8 means and y equals plus or minus 1/2 x. So you're going to go up 1 to the right 2, and then make your line. And then you're going to go up 1 to the left 2, and then you're going to make your line. So that's kind of what we're dealing with for this first one. So I found my 2 vertices, I found my 2 foci. Well, let me plot just the foci here. So it's like 3.6. So it's somewhere right around here and somewhere right around here. And then the asymptote would be denoted as y equals plus or minus 1/2 x. Okay. The second one is I have y squared over 16 minus x squared over 49 equals 1. So from here, I know that this is denoted as a squared and this is denoted as b squared. So a ends up equaling 4 and b ends up equaling 7. So what we have here is for our vertice, we're going to have it, because now this is a vertical one, because it's going to be the hyperbola is going to be positioned up and down. It's going to be 0, comma, plus or minus 4. Our foci, which is denoted by c, and that can be found with using c squared equals 16 plus 49. 16 plus 49 gives me 65, so that means that's going to be a square root of 65. So I'm going to go 0, comma, plus or minus the square root of 65. Now let's plot those points. So I'm going to go 1, 2, 3, 4, plot that. 1, 2, 3, 4, plot that. And then it looks something kind of like this. And then the square root of 65 is something like 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. It's about there. And then 1, 2, 3, 4, 5, 6, 7, 8. So it's right about there. So that's where the positions are for the foci. The last thing they want us to find is the asymptote. And that can be written as y equals plus or minus, and this one's going to be a over bx. So a is 4 over b, which is 7x. So that means that I'm going to have a slope. It's going to go up 4 to the right 7. So it's going to look, so I go 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So it looks something kind of like this. And the same thing goes here. And that is what we're looking for here. Okay. Last thing they're going to have is they're going to be given some points on um, our graph, and we're expected to write an equation from the information given. So they tell us that the foci is in coordinates -8, 0, and the vertices is at 5, 0. So this means that these two values are on the x-axis, so that means we're dealing with an x squared over a squared minus y squared over b squared equals 1. So this gives me c, and this gives me a. To find b, I can take 64, which is c squared, equals 25, which is a squared plus b squared. So I'm going to subtract 64 to 25, which gives me 39. So b squared equals 39. So I go y squared over my a would be 25 minus y squared over 39 equals 1. Okay? For b, this foci here tells us that the coordinate is on the y-axis. So that means that we're going to be using the y squared over a squared minus x squared over b squared equals 1. And then here, this tells us that since we're using that equation, I know that 2 equals a, and I know that 3 equals b. So it's just a matter of plugging in those values into this equation. So I'm just going to go y squared over 4 minus x squared over 9 equals 1. Okay? Last one. they tell us that we have a focus that's at 0 comma negative square root of 26, and we have a transverse axle length between the vertices, which is a distance of 2. Well, if you remember from page 1, let's take a look at page 1. It says that in both of these transversal axes that the distance is denoted as 2a. So if we go back to this one, so if 2a equals 2, we divide both sides by 2, that means a must equal 1. And then the focus there tells us that it's on the y-axis. So that means it's going to be in the general equation y squared over a squared minus x squared over b squared equals 1. And then this is also the distance for c. And then we can find b by taking c squared equals a squared plus b squared. So taking the square root of 26 and squaring, so that's just going to be 26 equals 1 squared is 1 plus b squared. Subtracting the 1 to both sides, I get b squared equals 25. So now I can write the equation as y squared over 1 minus x squared over 25 equals 1. And if you want to simplify it more, you can go x squared minus, or y squared, sorry, minus x squared over 25 equals 1. And that is being able to graph and write equations of hyperbolas. Hope this helps. Until next time.